Viscosity? The science behind fluidity. The concept of forces applied to the body by nature is not unknown to anyone. Even if a living or non-living thing both experience these forces to a certain extent. The frictional force which is exerted while friction is one among them. Suppose we roll a ball. You will observe that after covering a certain distance it would stop. Similarly, if you push a cart, it will also show the same characteristics. And this all happens due to frictional force acting on them. But what if we replace these solids with fluids? When we talk about fluids, it also shows this type of characteristic. This property of the fluid to flow either slow or fast is termed as viscosity. The measure of fluid's internal momentum resistance is described as viscosity. On the basis of resistance of fluids, viscosity has been classified into two groups or categories. High viscosity, low viscosity. There are some basic factors that distinguish these two categories from each other. We will use these factors to do an exhaustive comparison between high viscosity and low viscosity. Exhaustive comparison on different factors. High viscosity, low viscosity. They have high internal resistance to flow. They have low internal resistance to flow. When they are poured from one container to another, they remain in contact with the air for longer duration, due to which the ability of fluid to shear is too low. Due to their low internal resistance, the ability of fluid to shear is too high. The fluids have high internal momentum resistance, causing high viscous force, which obstructs the transfer of momentum. They have low internal momentum resistance, causing low viscous force, that does not obstruct and easily allow the transfer of momentum. The fluids have strong intermolecular forces leading to high internal momentum resistance, which causes viscous forces to obstruct the momentum transfer, causing it to flow at a slow speed and sluggishly. They have low intermolecular forces leading to low internal momentum resistance, easily causing transfer of momentum, due to which the speed is fast. The fluids have strong covalent bonds leading to strong intermolecular forces. They have weaker bonds leading to weak intermolecular forces. They have very high friction because of high internal resistance, causing viscous forces to obstruct the transfer of momentum. They have little or almost no friction due to low internal momentum resistance, leading to easy transfer of momentum. The above factors determine the viscosity of a fluid. Apart from these, we have two important ways to find and do a comparison of the viscous property of fluids. High viscosity versus low viscosity determination. Since the past, there are only a few methods evolved to both find and compare the viscosity of fluids. These methods are not only confined to comparison like rest, but provide us with an indicator as well as exact measures to know if the fluid has high viscosity or low viscosity. The viscosity of fluids mainly depends on the temperature. If the temperature of a fluid decreases, the viscosity increases, and vice versa. This change in viscous property due to change in temperature brought a lot of problems while comparison. To solve this problem, an indicator scale for comparison using relative property was decided to make. For this, a suitable and familiar liquid, i.e. water, has been chosen. Everyone was familiar with the speed of flow of water at room temperature. Due to this characteristic of water, it was started being used as viscosity indicator or basis of viscosity index. According to this index scale, the fluids which have high viscosity than water are termed as high viscosity fluids, while the ones whose viscosity are less than water are termed as low viscosity fluids. Now, there are many different types of viscometers, a device that is used to measure the coefficient of viscosity, that were developed from the past to the present. These are used for finding the exact measure of the coefficient of viscosity of fluids for comparison. Viscosity of some fluids. Here are examples of a few fluids with their coefficient of viscosity mentioned in the table given below. Fluids viscosity in centipoise: air 0.018, helium 0.019, acetone 0.316, gasoline 0.6, water 1, ethanol 1.095, mercury 1.3, kerosene 1.64, milk 3.2, blood 3. For cream 14 vegetable oil 34.6 tomato juice 176 glycerin 1000 2000 honey 2000 3000 mayonnaise 5000 molasses 5000 10,000 chocolate syrup 10,000 25,000 Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.